Hey everyone, welcome to Lesson 9, Video 1 on radicals and conjugates. This is our first page of guided notes. A little bit of this is going to be review because we're going to be simplifying radicals, and it's important that we have some understanding of some of the previous concepts. So let's go ahead and get started. So number one, a prime number. What is a prime number? A prime number has exactly two factors. Okay, and these factors are 1 and itself. Okay, and the first prime number is 2. Okay, so for example, 5 is prime because the only two numbers that go into 5 are 1 and itself. That's what that means. Okay, so 5 is prime. Okay, so every whole number greater than 1 is either a prime number or a composite number. Okay, those are our two options. Prime or composite. A composite number is made up of various parts, okay? And we're going to talk a little bit more. It's made up of various parts, and you can get every single composite number ever, like 12 or 16, by multiplying a single set of prime numbers together. So you can get every single composite number by multiplying a single set of prime numbers together. Okay, prime factorization means that we're finding a set of primes that multiply up to give us multiply to a given composite number. Okay, and so this is the idea that we have to take into radicals, all of this. Okay, but we're going to start by using what we call a factorization or a factorization tree. So example 1 again is review, and so what we're doing here is find the prime factorization of 18. So what that means is 18 is composite. Okay, there's more than 1 and itself that go into it. So if I look at 18, how can I break it down into prime numbers, a product of primes? And so prime numbers are like 2, 3, 5, 7. Okay, so let's break this down. So we have, let's just take two numbers that multiply to be 18. And I'm going to pick 9 and 2. Okay, you could also have done 6 and 3. So 9, now 2 is prime, so that's done. I can't break that down anymore. 9 can be broken down into the product of 3 times 3. Now notice all these last digits, 2, 3, and 3 are prime numbers. So the prime factorization, 18, is 2 times 3 times 3. You could also write this as 2 times 3 to the second power because you're multiplying those two together. Okay, so that's what we're going to take into the square roots. So let's kind of look at this next idea. The square roots in higher order radicals. Okay, a number r is the square root, okay, the square root of another number k if r squared equals k. For example, 4 is the square root of 16 because I can sit and do 4 squared equals 16, right? 4 times 4. Just like negative 4 is another square root of 16 because negative 4 squared is 16, right? So they're taking that idea. If you square a number and you get a value k, that number r is the square root. Okay? The radical sign r is called, well, it's called the radical. It's a radical sign. We call that the radical. And it also denotes what we call the principal root. Okay, that's the positive answer. The principal, it's called the principal root. Okay, and it's the positive root. Okay, and this is the one you get on your calculator. So if you do the square root of 49, it's going to give you 7. It's not going to give you the negative 7. Okay, so now let's extend this idea of square roots. We have no number where the index is, and we're taking the square root of 60. So we're going to do that by prime factorizing that. So we're going to take 60 and break it down. And we know that 60 can be broken down into 10 and 6. 10 can be broken down again into 2 and 5. Those are both prime numbers. and 6 is equal to 2 times 3. Now, when we simplify this, the square root of 60, that's going to equal, we're going to rewrite this. And we want, this is a square root, so we want all our powers to be written in powers of 2 if we can. Notice we have 2 and 2. So 60 here is 2 times 2, or 2 squared, times 3 times 5. So we're going to put that there. 2 squared times 3 times 5. Now, whatever has a second power is coming out. Miss Caesar says when 2 become 1. See that power of 2? That's going to cancel with the radical. So 2 is going to come out. These are both first powers, 3 and 5. They don't come out, so 3 times 5 is 15. They have a power of 1, okay, which is lower than our index of 2. So there is the simplified version of square root of 60. It is 2 times the square root of 15, okay? So that's the end of the first video. We're going to go ahead and do examples 3, 4, and 5 coming up. But we're going to start with just this video. So if you have any questions or comments, let me know, and we'll see you next time.